everyone. Thank you all for joining PAVE's virtual panel series. My name is Tara Andringa, and I'm the Executive Director of PAVE. Today, we're talking about testing. Our mission at PAVE is to help the public understand AV technology, and there may not be any AV subject that is more important and more complex and yet less understood than testing. So today, we have three experts to help explain the hows and whys of AV testing. I would like to welcome our guests. Michael Fleming is the CEO of Torc Robotics. Hi, Michael. Rachelle Celebrezze is a Senior Manager of Government Relations at Cruz. Hi, Rachelle, welcome.
Hi.
And Alex Lybarger is a Senior R&D Engineer for the Transportation Research Center in Ohio. Hi, Alex.
Hello, everybody.
Hey, thank you all for being with us today. We received a lot of questions from the audience on this topic, so we were excited that there was so much enthusiasm, and we will try to fit in as many of your questions as we can. But let's just start with the basics. Michael, why is testing so fundamental to AV development?
Sure. Well, first of all, Tara, thanks for having me here, and it's a pleasure to meet everyone virtually. You know, the answer is actually pretty complicated because it's multi-dimensional. I think a lot of us view, testing as, hey, we've developed a product, we understand the requirements, and there are, test procedures that have been, refined for, years over years, and it's actually a little bit more multi-dimensional. I started my engagement in self-driving technology back in grad school at Virginia Tech, and started Torc, and we partnered with Virginia Tech and the Urban Challenge, crossing the finish line third. And at that point, we really felt that we were pioneers of this technology. And it's interesting to look at the way that we tested, about 13 years ago, and the way that we tested today. It was much more reactive testing, to compete with some of the basic rules and the DARPA challenge. But when we partner with different OEMs, and of course Torc is part of the Daimler family. Today we're much more focused on not a project but a product. And when we focus on a product, there are a lot of different things that are changing. The ODD, the environment that we operate in, we may not fully understand that. So, a lot of times that's an element that's evolving. A lot of folks talk about the software stack and the hardware stack, where, we're doing a lot of work in simulation, whether it's SIL or whether it's HIL. And then there's also a lot of, on-road testing that's being done as well. I think there's a lot of misconceptions out there as far as what organizations like Torc and the organizations from the other, panelists do in on-road testing. I think that the folks who have been doing it for, quite some time, there are a lot of safety procedures that are in place. We make sure that we, thoroughly vet the technology before we bring it on the road, and we have a lot of redundancy built in. But, when we're testing on the road, this is real interesting. We can think of all the different scenarios, but sometimes we miss them because drivers are human, and drivers often do things that are unpredictable. And when you have one human driver, it's kind of easy to come up with what they're going to do. But what happens if you have a half a dozen or a dozen, and think about all the different environments? So, at first we start missing some of these scenarios because we don't think of them. We're able to kind of come up with a more comprehensive scenario book by doing some of the on-road testing. So it hits a lot of different elements of the development process, but we're still at the early phase. I would even say it's the Wright brother phase of self-driving development. And I know there's a lot of media and publicity that, hey, a product is right around the corner. In my opinion, we still have quite a ways to go.
Right. And Alex, Michael talked about on the road testing, and we had some interest from the audience about there are different types of testing: simulation and closed course testing, on the road testing. And people were interested in what the different types of testing are and the role that each plays in development. Can you describe the different types of testing scenarios?
Yeah, absolutely. And I can start with simulation because people usually talk about simulation first. So that's where we can, and developers and test houses like TRC, where we can almost, I'm using the term cranking through scenarios. So it's where we can get a lot of data very quickly. It does come from, and those scenarios are generated from data gathered while doing public road drives and other closed course tests, and from standards as well, from NHTSA or IHS. And it gives us a baseline. And that's really what simulation does. It allows us to do a lot of trials, but with it's all dependent on the fidelity of the model. So there's a lot of items and variables that go on with simulation. And so your model is only as good as what variables you feed into it. So it kind of goes to the next step of where TRC kind of has our bread and butter, and that's in the controlled environment prove out and testing space. So what we do in our facility is this is where we can do safe, repeatable, controllable tests. And so really what you can do on a closed course is you have the sandbox, so you can set up different scenarios, and the biggest thing is that repeatable word, because every time you run the scenario, you want to see how your vehicle handles it over and over again, and then also compare to other vehicles. So that's how standards kind of originate and form based on a specific scenario that you repeat over and over again, so you can kind of compare apples to apples. Then moving into the on-road, there's two kind of steps to on-road deployments. One is just data collection. I kind of talked about that in the simulation side, where you don't even need to have the systems active. You just need to have the sensor suite that's going to be on the final vehicle out there, collecting data to feed back into the on-road, to the controlled environment prove out and the simulation. Then you also have those deployments where you want to make sure that you're covering those unknown unknowns, those things, those edge case scenarios that are going to come out that you haven't seen before. But I know this is one of the other questions that was posed, but when we're talking about miles and our miles, what do miles mean? What do disengagements mean? And this is where it really gets into the miles matter. If you just drive around the same block a billion times, yes, it might be a 1 billion miles, but it's not what you really want. You want to stress the system. You want to make sure you hit as many of those edge cases as you can. So I know some of the other panelists can probably expand on that, so I'll stop here.
Right, and Rachelle, kind of pulling that all together, I wondered if you could talk about how all of these types of testing combine to create a rigorous testing program. And some viewers were curious if it's sequential, like you start with simulation and then move to closed course, or if all of these different scenarios are used throughout the development process.
Great, and thanks. And again, just echoing, thanks to PAVE for inviting Cruz to be part of this important conversation and joining my fellow panelists. To sort of let you all know, in case you didn't, Cruz is an all-electric autonomous vehicle company. We're headquartered in San Francisco, and that is where we do our real-world testing. And so I'll get into that in a little bit, but just wanted to kind of ground you on who we are and what we're doing. Before I get into how we view our testing and how we've developed our testing, I did want to hit on the topic of safety, because I think that that's something that we all really want to make sure that we stress when we're talking about testing and just help to educate the public on how we're doing it safely. I think that's been a big question. So at Cruz, safety is our North Star. That means that we've embedded it into everything that we do. It's at the forefront of really our goal, which is to create an autonomous driving system or an autonomous vehicle that is truly superhuman. And so what does that mean? That means that we're going to be looking to improve the safety on our roadways, because the AVs won't fall prey to the same risky human behaviors. They're not going to get distracted. They're not going to drive impaired. They're going to follow the rules of the road. And so I think that that's an important way to sort of ground us in the conversation. And because that safety is our ultimate goal and we've built it in throughout not only our driving system through redundant sensors, redundant computers, but also in the testing process. So that's a long way of getting to, we use all three, and it's not a, if you do A, then you move to B, and then you do C, and then and then you're done. It's an iterative process where we learn from all aspects of training of that testing. So we have a three-pronged approach. It's an all of the above. We use simulation, we use closed course testing, and we use real-world testing. For a lot of the reasons that have already been discussed. In the closed course testing, what we're learning there is really the limits of the autonomous vehicle. We're learning, how does it react on turns? How does it do, things when we're looking to really test those limits? on the simulation, that's when we can really build those complex scenarios based on real world data. And then in the real world, and this is where I think we can really add some value, we are testing in the extremely complicated and complex environment of San Francisco. Prior to COVID-19, we were testing in San Francisco 24/7 in the full, what's known as 7x7 of San Francisco. So the hills, the double parked cars, the jaywalkers, pedestrians, bicyclists, construction, all of these things that happen to a human driver, our vehicles are out on the road learning and collecting that data. And I think one thing that we didn't touch on is in bringing all these pieces of testing together, we have a fleet of vehicles that are out learning. So the benefit of fleet learning from the real world testing is that what one vehicle learns and that we run through simulation later, or maybe there's something that we want to tweak on the closed course testing track, all of the vehicles will eventually learn that. And so we're able to actually improve through the fleet model much faster and iterate much faster. So I think that's the highest level is we use all of them. It's not a straight linear process, and it's completely iterative. You know, we're constantly working through all three kinds of approaches.
Absolutely, thank you. And Michael, so that was kind of an overview of the passenger vehicles that Cruz is working on. How is testing AV trucking different than passenger vehicle testing?
Sure, yeah, it's a great question. And actually, there's a lot of similarities between Torc and Daimler Trucks and Cruz and GM, in my opinion. You know, we're an entity that is responsible for one thing, focused on, you know, self-driving trucks. And if you look at, you know, what Rachelle was mentioning, that the 7x7 in San Francisco, you know, our operating environment's a little bit different. It's highways and interstates. So I think you could argue it's maybe a little bit easier than the 7x7 in San Francisco. Of course, we drive at, you know, much higher speeds. Obviously, I think that the business cases are a little bit different, but how we go about development is very similar to what, you know, Rachelle outlined. It starts a lot with, you know, the requirements and understanding, you know, your operational design, you know, domain, which is very different on I-40 as opposed to the 7x7 in San Francisco. But there is sort of a parallel process sort of going on between requirements, system redesign, SIL, HIL, closed course testing, and real world testing. What we find is in simulation, you can test much more cost effectively than in the real world. And then there are some, you know, tests that you want to conduct on closed courses that are quite frankly unsafe to validate, you know, in the real world. And, you know, we've been to TRC and Alex's facility, and it's just, you know, top notch. We've been, you know, very pleased there. So I think a lot of similarities between, you know, Cruz and Torc. It's just in my opinion, we're focused on, you know, two very different markets. And one of the big benefits that we have, I think, being with Daimler Trucks, the market share leader within trucking, is they have a lot of information and data from, and it's actually very intriguing. I mean, they invented the combustion engine, they invented the car, they invented the truck, and they have the market share within the U.S. We're able to leverage a lot of that, the data and history that they've, you know, collected from on-road truck testing and bring that into simulation to help complete the scenario book for situations that we may not come up with, but then also, you know, to provide some insight and guidance on what the appropriate thing to do in these different scenarios and situations are, which, you know, I personally believe is one of the most difficult parts of developing a self-driving vehicle.
Mm-hmm. Absolutely. Another thing, Alex, one of the most common questions we deal with at PAVE is the role of the test driver, and people's confusion about, is a car really autonomous if there's a test driver, and what is the role? Right now, there are test drivers in the vehicle in most real world testing scenarios. Can you just describe big picture, what is the role of a test driver?
Yeah, and to cover one of the points, Michael already mentioned that we're still a ways away from having the unmanned vehicles on the roads. There's a couple instances that we do in the U.S. have unmanned vehicles running, but for the most part, you will see those safety drivers, and their role is to make sure and be that fallback ready essentially operator when a fault happens, because these are still prototype systems. These are still under development. And so they need to be engaged and ready to take over. So there's two different types of problems, and you can see, and they're kind of new with this type of driver or operator. It's, you have overstimulation and understimulation. So you have the, I'm driving for many miles and the car's driving itself, nothing's happening. So you're just kind of waiting for it to happen, and you could get tired or do other activities, where this is something we need to make sure that our drivers, our operators are always ready to take over. And so that's a new mentality, that because for TRC, we've been around since the 70s, and we have a pool of drivers that have been running these long mile durability programs. And so they're used to holding the wheel, driving all these miles. So now throwing them in these new vehicles, it's a new training program and a new process that we have to go through. The other is the overstimulation, where it's, I'm in a new toy and there's all these things, there's a LiDAR image there, you can see what all the sensors are seeing. And so it's not getting caught off guard by the shiny object. It's making sure that you're focused on what your task is at hand. And so it's a very rigorous training program, and a bunch of companies have already hit on, or at least alluded to, what they've been doing. And it says voluntary safety self-assessments that you can find, or VSSAs, online. So you can, for those of you out there, you can go on NIST's website and see those different, what each company is doing that has filled out one of those.
Great, thank you. And Rachelle,
Can I insert one thing?
Absolutely,
because I think close the loop on a couple things, just to give the audience something more, tangible. One of the things that we spend a lot of time on is lost cargo. And you can imagine driving in the real world, and lost cargo is essentially, you could imagine a refrigerator falling off of a vehicle in front of you, to a golf ball falling off in a vehicle in front of you. And in my opinion, no one is really there with a very robust lost cargo system. I think this is something that is still evolving. And clearly, if we're on a public road and an object falls off the vehicle in front of us, our safety drivers are trained to immediately take over. The reason behind that is we haven't validated our lost cargo capability to a robust enough fashion. So that's where we'll go to like a TRC to do some of the lost cargo real world testing on a closed course. But of course, we take that data and a lot of other data that we create virtually and validate that in simulation. So I think it's important that the testing is actually done both ways. It's not sort of a left to right. There are a lot of different connectivities. So
great, yeah, I would definitely agree with that. And to kind of go back to the two, what we call autonomous vehicle test operators, or AVTOs, the safety drivers, we have two in the vehicle at all times. And it gets at a lot of what Alex was saying. We have someone who's behind the wheel, who's poised to take over at any point that that person feels like they need to intervene. And there could be a lot of reasons for that, and I can get back to that in a second. But we also have someone who is sitting in the passenger seat, and that person is our designated note taker. They're noting things about the road, about the route, and so you don't have that overstimulation issue. There's also a lot of safety that's baked into that program as well. Why do we have two AVTOs in the vehicle in the beginning? Again, redundancy. We don't want understimulation, we don't want overstimulation. We also we have a very intensive 6-week training program for our AVTOs before they get in the vehicle. And once they're in the vehicle, we have, to combat fatigue, we have a lot of rest breaks, and then also the two AVTOs will switch positions to make sure that they are continuing to be engaged during their shift. We also don't allow personal cell phones in the vehicle. So again, that reduces the probability that there's any kind of outside distractions. And then, we also build safety into the program by training our autonomous vehicle test operators with how to interact with law enforcement should that be necessary. And so, there's a lot of other ways that we're building safety into the testing, specifically on this real world testing, to make sure that we are doing this to make sure that we're doing this in the safest way possible. But also something that we've all talked about is gaining that public trust. And so if one of the great things about these kinds of webinars is that we can talk about specifically what we're doing and engage with the community in that way and let them know, yeah, we've thought about these things and we care deeply about it. And that's why we've structured our programs this way.
Great. And your point about law enforcement, it leads to another question we got from the audience. Michael, I'm curious, you can talk about this. There was some interest about where people test, and a lot of factors go into those decisions, including weather and infrastructure and local regulations. What are some policies and protocols or government relationships that you need in place to ensure that road testing is done safely?
Sure. Yeah, this is a great question and very intensely debated at times. You know, how much regulation should states and the government have in self-driving? To me, it's less of a question on how much regulation and more of a question on ensuring that there is a dialogue going on. I mean, this is a journey that is, as I've always put it, it's a marathon. You know, it is not a sprint. We don't want to over-regulate. We don't want to under-regulate. I think it's important that the panelists and other developers, you know, within the self-driving community is sharing the appropriate information with the government entities that are considering, you know, passing some of this regulation. When we look at developing a self-driving system, I think the first thing that we want to do is try to target the region in which we want to deploy self-driving trucks in phase 1 as opposed to phase 2 and phase 3. So, you know, Torc and Daimler are, you know, heavily involved in that discussion. I know Rachelle's background, I think, has a lot to do with this. So I may pass the baton to Rachelle here because I know this is your area of specialty.
Yeah, and thanks. And so, you know, just to hit on what Michael was talking about, really working with our regulators and our community is key to this. And so we are still very much in the testing phase, I think, as an industry. And so having these kinds of robust conversations that we're having today, and then also going in and meeting with our regulators and our local elected officials, our community groups, to make sure that they understand that, you know, the VSSA, the voluntary safety self-assessment that we've all filled out and filed with NHTSA, you know, that is just the start of where we're all at, and that we are really thinking and putting safety as our North Star. And so, you know, just kind of going back to what I started with at the beginning of this webinar, we want to make sure that not only is safety embedded into our culture, but that we're having those conversations, and that as we move through this process, that our community, which includes our regulators, our legislators, and the public at large where we're testing, understand that we are taking safety extremely seriously, and that we're building it into all parts of these processes, so that when they see the vehicles on the road in our real world testing, they also understand that we've built the two AVTO testing operators into the equation. We're also working on simulation to make sure that we capture those edge cases. You know, one of my favorite examples here in California is in San Francisco. We had someone crossing the street who had a palm tree hat on, and our vehicle said, "Is that a tree? Is that a person? You know, what do we do?" And so, you know, it's a fun way to, you know, explain. We never would have thought of putting that in a closed course test, probably not even in our first run at a simulation. We saw it on the roads. It's something that we've addressed, but it's a fun and accessible way of explaining how we're building that safety in, and we're taking those real world scenarios. So I guess I would just say, you know, we would encourage regulators and legislators to maintain that flexible framework and continue to work with us and have that open dialogue. And, you know, really, when there are questions and concerns, come to us and have that conversation rather than, you know, implementing legislation or regulations, because there may not actually be an issue. So we want to make sure that those lines of communication are open.
And Tara, I would say that I'm very pleased with how the regulators have approached the self-driving industry. I think that it's been done well, but like anything else, and we can always improve. Just a tidbit of information. I remember I had a one-on-one with the senator, and he made a comment to me. He goes, "You know, Michael, I sit in these different briefings and I see these different you know, press releases and headlines, and I don't know what to think about this. Can you provide some ground truth?" So I think it's up to us to really engage the influencers and the regulators, as opposed to us being on the heels. And I think they're seeking that guidance and that understanding as well. I don't think we need to educate them to the point that they're a PhD roboticist, but how can we take some of this complexity and articulate it in simple, like layman's terms?
Absolutely, and I did plug for PAVE that's our mission, is to try to engage the public and policymakers in a conversation about AVs. Wanted to touch on one other thing that we got a lot of questions about. You both you all are talking about how safety is at the heart of everything developers do. And then there's always the challenge of how you measure safety. And we got a bunch of questions about disengagements. Alex, just curious, we want to start off really basic? Can you describe what a disengagement is?
I mean, it's very simple. When your system either encounters something that's outside of its ODD or something it cannot, in simple cases, it cannot handle, and it hands over control, whether that be, or goes to a fallback ready condition, where a minimal risk condition, where it may pull over the side of the road, or it does hand it back to a safety operator. And so to kind of dive into that, disengagements are kind of the initial, what everybody was saying, that where does my system stop working? But then you get into as we get into the different systems, and we see this as kind of a third party, being TRC, where some people want to make sure that they have a low disengagement count, so they'll be a little bit more risky when they're out on public roads. Other people want to be very safety cautious, so they're telling their safety driver to take over before there's even a disengagement. So that causes a manual override, which can be classified as a disengagement. So we've been looking at different areas, and there's some metrics out there. Instantaneous safety metric, which is actually written by one of my colleagues at TRC. Also, Intel released something, RSS, safety force field from NVIDIA. And then there's these new metrics that are slowly coming out, leading and lagging metrics. I'm throwing a lot of words out there just so everybody I'm realizing we're running low on time and giving other panelists some time to speak. But these are some things you can always Google, you can always reach out. There's a lot of resources on these different types of metrics, but right now there's no one size fit all metric for this. And I'll let the other panelists speak on this now.
Well, I wanted to, touch on that. Rachelle, earlier this year, Carl Vogt, the co-founder of Cruz, wrote a piece called The Disengagement Myth. And he said that it's misleading to say that disengagements are a meaningful signal of readiness alone. Why are disengagements alone not representative of a vehicle's readiness?
Yeah, thanks. And I think that this touches on some of the things that Alex was saying. I mean, disengagement is at its heart when in our case, in the real world scenario, the AVTO takes over. And there's a lot of different reasons that the AVTO could take over. There could be something happening in the moment and they feel like they're not sure what the vehicle is going to do. And so they're going to take over. And things happen very quickly. And we want to make sure that safety is at the forefront. So again, that's why we have them in the car. What we do though is we come back and we run the simulation of what was the car going to do. And what we found is in most cases, the car was actually going to, the Cruz AV was going to act in the manner that we needed to. And conversely, we've also found that sometimes when our AVTOs take over, that it wasn't the right decision. And if the Cruz AV had been able to continue on its path, it would have made a different choice and it would have averted some sort of issue. So, the disengagement myth that it shows safety or it shows progress toward readiness, it doesn't actually do that. It shows you how many times a human decided to disengage the Cruz AV, and that's not necessarily the same thing. There are a lot of reasons why that happens, and again, going back to safety, we want to have that person there so that if it is one of those cases where the AV would not have made the safer choice, we have that person there, but that's not always the case.
And I think that brings up an interesting point. I'm going to try to get in one last question, Michael. I'll send it to you. Someone from the audience asked whether vehicles learn, whether after being on the mile, after so many miles on the road, whether they actually are taking in that data and reacting better, whether developers actually need to manually make changes? I thought that was an interesting worded question. Wonder if you wanted to tackle that.
Yeah, a while back there was some discussion on end-to-end deep learning was the path forward. We didn't believe that. We believe that machine learning and deep learning has a role to play in the software stack, but it's not the entire software stack. This is a system integration problem of a lot of different technologies that have to come together to create the right balance between performance and cost where safety is not compromised. And when I look at safety, I know there's a lot of discussions on like what is safe, and as an engineer, I would want numbers to determine are we green, are we red? But I disagree with that approach. I believe it is a qualitative approach that is supported by quantitative metrics. And with the disengagement KPI, and I'll try this analogy for the first time, so we'll see if I face plant here or not. But I was thinking about it this morning, how to describe it. It's sort of like a baseball player and saying, is this a good baseball player? And they may bat 1,000. And a lot of folks would say batting 1,000 is probably a pretty good baseball player. But what if you've only had one at bat? Okay. And, or maybe you have a 0% batting average and you've had one at bat, but that at bat was a walk. So you have to look at this very multidimensionally, and there's a lot more KPIs there. And this is a problem that we spend a great deal of time that is just highly complex. And it's difficult to really, present and digest that in a simple fashion. And I think that's one of the reasons that a lot of society is struggling in understanding how all those different KPIs, come together. Really, there's a domain, there's domain experts, at Torc and Daimler that are working on this problem, day and night. And I hope eventually it sort of becomes a standard. And I think this is where forums like what we have today with PAVE and some of the other partnerships between OEMs and AV developers will play a pretty important role. In my opinion, we can't have multiple standards. We're going to have to converge as a community on a common standard.
Great. Well, we are sadly out of time. I want to thank our guests, Michael, Fleming, Rachelle, Celebrezze, and Alex Lybarger for joining us today. And I hope you all will join us next week for PAVE's 12th virtual panel. Thank you all.
Thank you.
Great. Thanks for having us.